Now, if I have to do a process called rationalizing the denominator, well, usually answers are written in their simplest form, meaning that if I can simplify the top and the bottom, then I'm going to divide out the common factor. When we're talking about rationalizing a denominator, it means that the denominator cannot have a radical in it. So I don't want, anything like root 6 over root 5. That root 5 needs to disappear. So if I need to get the radical out of the denominator, then I'm going to have to multiply the top and the bottom by something that will eliminate the radical. And we've actually encountered this. We've said, well, if we have root x times root x, then that's going to be root x squared, which would just be x. We can use the same principle for rationalizing a denominator, which we're going to see right here. If I have the square root of 10, and I'm dividing that from 1, and I have this down in the denominator, I can multiply the numerator and the denominator by the same thing to still keep an equivalent radical and an equivalent fraction. But then if I have root 10 divided by root 10, this would be the same as root 10 on the top and the square root of 100 on the bottom. Well, the square root of 100, or the square root of 10 squared, is just going to be 10. And I don't have it in the denominator anymore. Now, I only need to do that for whatever the radical is. I don't need to worry about coefficients. So in this case, even though I have 2 root 6 on the bottom, I don't need to multiply the top and the bottom by 2 root 6. I can just multiply it by whatever the radical is. In this case, the square root of 6. So I'm going to say that if I multiply the top and the bottom by the square root of 6, well, 20 times 6 is going to give me the square root of 120. And on the bottom, I'm going to have 2, and root 6 times root 6 is just going to eliminate the radical and give me 6. Well, this can be simplified. The square root of 120 I can simplify to 2 root 30. 2 times 6 is going to give me 12. And what's outside of the radical has a common factor of 2. So I'm going to divide both those by 2 and just get root 30 over 6. In the last case, we're following the same process where we have root 5 in the denominator, so we multiply the numerator and denominator by root 5. And we're going to get the square root of 90 over 5, and it's going to eliminate that radical in the denominator. The square root of 90 I can rewrite as 3 root 10 over 5. And because there is no common factor here between the 3 and the 5, I can't simplify it beyond there. That's just my final answer. So, if I'm expressing each numerator and denominator in its simplest mixed radical form and then rationalizing, well, all it wants me to do is just simplify as much as possible before I even start. So I could do my factoring tree for the 500 and for the 27 and then say, well, this is just going to be 2 in 250, 2 in 125, 5 and 25, and then 5 and 5. And we see that we have a pair of 5s, a pair of 2s, and a 5 that's left inside. So this would be the same as 2 times 5 times the square root of 5. And on the bottom, the 27 just splits up into 3, 3, and 3. It's going to be 3 root 3. This is the same as 10 root 5 over 3 root 3. Well, now, as opposed to having to multiply the top and the bottom by the square root of 27, I can multiply them by the square root of 3 to cancel out the radical. So I can deal with much smaller numbers. So I'm going to say that I have 10 root 5 over 3 root 3, and I'm going to multiply the top and the bottom by the square root of 3. Remember, anytime that we get rid of a radical, I'm going to replace it with brackets to make sure that I multiply it properly. And I can just say that this is going to be 10 root 15 over 9. Now, if I had multiplied the top and the bottom by root 27, I could still get to the final answer. I would just need to simplify at the end. And I'm also dealing with much, much bigger numbers. I'm going to do the same thing with the second example. So I have 3, and I'm going to simplify that square root of 240. So for the square root of 240, I'm going to call it 4 root 15. The square root of 108 is going to be 6 root 3. This is going to give me 12 root 15 over 6 root 3. And at this point, I can simply divide these out. I can divide the 12 by 6 and get 2. And I can divide the 15 by 3 and get root 5. And I don't actually need to multiply the top or the bottom by anything because I don't have a radical in my denominator just from simplifying. For the last example, it wants us to simplify the radical expression by rationalizing the denominator first, and then by dividing each term in the numerator by the denominator. So, for the first one, I'm going to say that I have 2 root 50 minus root 14, all divided by the square root of 2. Well, if I need to multiply the top and the bottom to rationalize the denominator by the square root of 2, I'm going to make sure I put brackets around here. And the reason for this is I need to know that I'm going to multiply the root 2 into both the terms that exist at the top using my distributive property. And I'm going to multiply the bottom by root 2 as well. So, in this case, I have 2 root 100 minus the square root of 28, all divided by 2. I can simplify what I have here. This is going to be 2 and the square root of 100 is just 10, minus the square root of 28 is going to be the same as 2 root 7, all divided by 2, or 20 minus 2 root 7, all divided by 2. Now, because I have the 2 terms on the top and the 1 term on the bottom, I need a common factor of all of these, or I'm going to divide out from all 3 of these parts, just like what we do when we're doing the quadratic formula. And I'm going to wind up with 10 minus the square root of 7. Now, if I do it the other way, I should wind up with the exact same answer. If I have 2 root 50 minus square root of 14, all divided by the square root of 2, then I'm going to divide the square root of 2 from each of the terms individually. And I'm going to get 2 and the square root of 25 minus the square root of 7. The square root of 25 is 5 minus square root of 7, which which is going to give me 10 minus root 7, and I get the exact same answer, no matter which way I did it.